Hello, this video is for the Algebra 1 textbook lesson. That's Chapter 4, Lesson 5. And this lesson is titled Scatter Plots and Trend Lines. The objectives of this lesson are to create and interpret scatter plots and also to use trend lines to make predictions. The vocabulary words for this lesson are scatter plot, correlation, positive correlation, negative correlation, no correlation, and trend line. So who uses this? Well, ecologists can use scatter plots to help them analyze data about endangered species such as ocelots. We see an ocelot here, picture of it. An ocelot, and I know it's pronounced that way because I Googled it and checked it. And also while Googling, I found out they live pretty much in southwest United States, Mexico, and the northern portions, and I believe also along the west coast of South America is what they said there. So in this chapter, you have examined the relationships between sets of ordered pairs that we also call data. Displaying data visually can help you see relationships. That's the whole idea of making graphs, is that we can see the data visually represented so we can make some sense of it and hopefully make some predictions. A scatter plot is a graph with points plotted to show a possible relationship between two sets of data. A scatter plot is an effective way to display some types of data. And the key is about a possible relationship. We've been doing graphs in which there was some relationship, things like how many tickets you buy determines how much money you have to spend. There is a definite relationship between the number of movie tickets you buy and how much money that you're spending. But sometimes there's not a relationship between the data. It could be positive relationship, could be a negative relationship, or it could be no relationship at all, which ought to give you a hint at some of these vocabulary words that we have over here. So let's look at example one. How do we make a scatter plot? So graphing a scatter plot from given data. The table shows the number of species added to the list of endangered and threatened species in the United States during the given years. And we have the years that are given here. Graph a scatter plot using the given data. So in 1996, there were 91 of them added. In 2000, there were 39 endangered species added. In 2002, there were 9 of them added. So first thing we want to do is go ahead and make a table or a graph. Every graph should have a name above it so you know what the graph is referencing to. Then you're going to have an x-axis and a y-axis in which one data set will be represented on one axis and the other axis will have another data set. In this case, we're putting the calendar year on the x-axis and the species on the y-axis. They've set up the graph so that it'll accommodate the data that we have, years being counted 10 years each, and our 10 species here, number of species being counted by tens. And then it looks like the years are what, 96, 96. Oh, they're just 1 year. Each tick mark is just 1 year. So use the table to make ordered pairs for the scatter plot. So what they've done is they take the table here, 96, there were 91, so 1996 they plotted 91. Let's look at 1998. It's paired up with 62. 1998, and this here's paired up where y is 62. And then finally 2001 is 10. So in 2001 right here, there are 10 of them. The X value represents the calendar year, the Y value represents the number of species added, and plot the ordered pairs, which is pretty much what I just said. And a helpful hint is to realize that the point 2039 tells you that in the year 2000, the list increased by 39 species, and that is an ordered pair, right? It's an X value. Let's see, I don't think I have my red. There we go. It is an X value and a Y value separated by a comma contained inside of parentheses. So indeed, that is an ordered pair. All right. One thing I want to point out about this, though, is sometimes graphs can be deceiving. Many people might look at this and say that the number of endangered species is decreasing. And actually, if we read it, it's the number of species added to the list. So always pay close attention to the title and interpreting what the graph is saying. Some people might look at this and say, oh, look, the number of endangered species are going down. No, this is a table that represents the number of species that are added each year. And another thing about this table that I noticed as I was preparing for this is that if this trend keeps going, it seems to be a downward trend. As the number of years increases, the number of species added seems to decrease. at some point you would think it would get down here into where the value of y is negative. Well, you can't add a negative number of endangered species, so and there can't be a negative number of years. So you really have to pay attention whenever you're talking about real life situations of the type numbers that you're working with. In this case, years, only the number of years can be positive, and only the number of species added to the list can be a positive number. So everything's done up here in what is known as quadrant 1 of the coordinate plane. Let's go ahead and look at our next page here and talk about a correlation. What is a correlation? Well, a correlation describes a relationship between two data sets. A graph may show the correlation between the data. So if you graph it, you can visually see the possible relationship between the two types of data that you have. Again, the main purpose of creating graphs in the first place is to be able to analyze it and make predictions. The correlation can help you analyze trends and make predictions. Imagine that. There are three types of correlations between data. And these are the three types down here in our correlation box. Positive correlation. This is a case where both sets of data values increase. So as we would read it as x increases, y increases. So that's an uphill. The pattern seems to go uphill from left to right. That is a positive correlation. X increases, y increases. A negative correlation is whenever it looks like it's going downhill from the left to the right. One set of data values increases as the other set decreases. So as x increases, y is decreasing in value. That is a negative correlation. And then there's no correlation. Something that looks like this. Somebody looks like they just loaded up a shotgun with buckshot or bird shot and just shot at a target and just sprayed it all over the place, right? Well, there's no uphill pattern, there's no downhill pattern, so there seems to be no relationship between the two data sets whatsoever. So this is what we would refer to as no correlation. In the endangered species graph, we would say that as time increases, the number of new species added decreased. So that type of correlation, that would be a negative correlation. So example 2 is describing correlations from scatter plots. Describe the correlation illustrated by the scatter plot. Again, every graph should have a title. This is TV watching and test scores. Imagine that, propaganda for students. So apparently, as you graph this, you see the number of hours spent watching TV increased, and the test scores for those matching data points decreased. So they asked somebody, how many hours of TV did you watch? Let's see, it doesn't say the time period, right? Say in a month, and they're like, oh, I watched 12 hours in a month, and then they take their test score and they got a 36, right? And so that that kid's like down in here someplace. A lot of TV time and low test score. And they did this with, it looks like 3, 6, 9, looks like 10 different people that they asked this question of. And then they graph the points out and end up with the scatter plot here. And so they then say, well, there seems to be a negative correlation between the two data sets because as the number of hours watching TV increases, the test scores decrease. Yes, hours of TV watching increases, the test scores, they decrease. Negative correlation. It looks like a downhill slope going from left to right. Describe the correlation illustrated by the scatter plot here. Snowboard competition, and the x-axis is years going by, number of participants, it's getting greater. So it seems that as the years increase, the number of snowboarding participants increases. For some reason, snowboarding is becoming more popular. Here in example 3, identify correlations. Identify the correlation you would expect to see between each pair of data sets and explain. A, the number of empty seats in the classroom and the number of students seated in the class. Well, it seems like as students start sitting down, as the number of students sitting in the class increases, the number of empty seats is going to decrease. So that would be a negative correlation. If we were to graph that out, let's see, grab a line here. Let's look and see what that would look like. And we'll go ahead and change to a blue line. So there's a lot of empty seats up here at first. The room's full of empty seats, and as people come into the room, then the number of empty seats would decrease, and we would end up with graph that looks like it's like that way. Actually, the thing about it is, you really think about it, I think that would almost be a linear type of correlation. So I'm going to erase this here, save it for my next example. There we go. B, the number of pets a person owns and the number of books that a person reads last year. So they asked somebody, how many pets do you have? And they're like, I have 5 pets. And how many books did you read? I read like 2. So like here, how many pets do you have? I have like 1 pet. How many books do you read? Oh, I read a lot. I'm up here. And they would just keep asking this, and eventually you'd end up with these data points that are all over the place because whenever it comes down to it, the number of books that somebody reads has nothing to do with the number of pets they might have, unless, of course, they're reading a bunch of books about how to take care of pets. But they don't state that, so we just have to assume it's any books. And then finally, for C, the monthly rainfall and the depth of water in a reservoir. Well, the more it rains, the level of the water is going to go up in the reservoir. So as rain increases, let me get my line here. So as the amount of rainfall increases, we would expect to see the water level in the reservoir to increase as well. And so all those points would be creating kind of an uphill pattern. So we would say that it is a positive correlation. All right. Um, let's look at this over here. Identify the correlation you would expect to see between each pair of data points, the temperature in Houston, and the number of cars sold in Boston. Well, Houston's way down south in Texas, and Boston's way up in the northeast, so the temperatures are going to be very different, so you wouldn't really be able to compare the temperatures in the city, and I don't even know if temperature has an effect on the sale of cars. I would say that 3A would have no correlation whatsoever because the temperature in Houston has nothing to do with the number of cars sold in Boston. The number of members in a family and the size of a family's grocery bill. Now that one definitely would be a positive correlation because as the number of family members increases, well, that's more people they got to eat unless they're going to eat less. But my guess is they're going to have to buy more groceries, and so their food bill is going to increase. 3B would be a positive correlation. They're both increasing the number of family members and the amount of food. Number 3 is the length of time you sharpen your pencil and the length of your pencil. I got to laugh because I think a student standing over at the pencil sharpener, grinding that pencil down, looking at it, blow it and grind it some more because they just don't want to return to their seat. But the longer you sharpen your pencil, the shorter your pencil gets. So as you increase the amount of sharpening time, you decrease the length of the pencil. 3C would definitely be a negative correlation. Example 4 is matching scatter plots to situations. I believe that's the checkout. So let's go ahead and do this first. Choose a scatter plot that best represents the relationship between the number of days since a sunflower seed was planted and the height of the plant, and explain. Well, on the x-axis is the number of days, and the height is on the y-axis. This first graph, the sunflower plant, the sunflower seed, since a sunflower seed was planted. Okay, it's a sunflower plant. We got those where I live. Fields and fields of them. They're yellow. Many people know that. So as we start off here at 0 days, the sunflower plant's already over 60 inches tall, and then it gets shorter. Don't think so, right? There would be a positive correlation between the number of days and the height of the plant because it's going to grow each day. It's not going to be tall and start shrinking. Second one, check it out, negative numbers. The plant can't have a negative height, and we can't have a negative number of days. Everything would have to happen up here in the first quadrant, quadrant 1. So we can rule this one out because it's representing negative values. And finally, for graph C, we see that we plant it. It has no height at all. It's down in the ground. It sits there for, looks like about 10 days before it finally starts to grow, and then it starts getting taller and taller and taller. You can actually see kind of a curve developing here because might be exponential, but nonetheless, it does look like a positive correlation here. And over here, choose a scatter plot that best represents the relationship between the number of minutes since a pie has been taken out of the oven and the temperature of the oven. So, well, you take it out of the oven, it's hot, and the longer it sits, it cools. So we should be looking for a negative correlation because as the time out of the oven increases, the temperature decreases. So we can rule out C. That's not going to be it. And, oh, temperatures can't be negative, so we can rule out B over here. Everything should be in quadrant 1. So it looks like it would definitely be A. Looks like it's a 60, what is that, about 40, yeah, 200, 240, 280, so it's over 280 degrees. And it sits for about 30 minutes, and it gets down to just under 80 degrees. I would have eaten it right about here with some ice cream. Yep, so that's where I would have eaten my pie at. Let's see. Next slide. You can graph a line on a scatter plot to help show relationship in the data. This line is called a trend line. It helps to show the correlation between data sets more clearly. It can also be helpful when making predictions based on the data. So example 5, fundraising application. The scatter plot shows a relationship between the total amount of money collected and the total number of rolls of wrapping paper sold as a school fundraiser. Based on this relationship, predict how much money will be collected when 175 rolls have been sold. I'm suddenly having flashbacks to being in middle school selling candles trying to win that Tyco racetrack. You kids don't know anything about that. So we want to go ahead and first graph everything out, right? It says we graph it all out. Here's a graph here. Well, actually, this graph we've been given. So we're going to take that graph and we're going to draw a line that has about the same number of points above it and below it. Your line may or may not go through the data points. It doesn't have to go through. You want to be a line if you start making curves, right? So you just try to get to where you got about the same amount above it, the same amount below it. And the way that I've taught this often is picture these little dots as houses, right? A bunch of way back in the expansion days and people going out there putting farms out and between two towns. And then they're like, we're going to build a road, but the road's got to be straight. And so we're going to try to get it as close to your house as we can. Some people have longer driveways, the other ones will be shorter, but we're going to try to make it as fair as possible. And that's what this, to me, I picture these as farmhouses, and this is a road, and they're doing their best to keep the driveways as close as possible. The thing about that analogy is you probably don't want the road going right through the house. But nonetheless, that's pretty much the idea. So now we're going to find the point on the line whose x value is 175, because that's what the question is. Predict how much money will be collected when 175 rolls has been sold. Rolls is the x-axis, so we're going to find 175. We're going to go up here to the line of the function, see what the matching y value is, and it's 1200. So based on the data, 1200 is a reasonable prediction of how much money will be collected when 175 rolls have been sold. Brings us to the guided practice. Let's do some vocabulary. Apply the vocabulary from this lesson to answer each question. Give an example of graph that's not a scatter plot. Well, we've been doing a lot of graphs like that. Like, again, how much money you spend for movie tickets. It's a direct linear relationship. It has a slope to it. Every ticket's the same price. So regular line linear function graph would be not be a scatter plot. How is a scatter plot that shows no correlation different from a scatter plot that shows a negative correlation? Remember, no correlation is the one that looks like someone took a shotgun with bird shot, just shot a piece at the target, and the dots are everywhere on it. Whereas a negative correlation, it all kind of be squeezed in a way that looks like a downhill slope going from the left to the right. And does a trend line always pass through every point on a scatter plot? Well, you don't want the road going through the houses. No, trend line does not have to go through every point on the scatter plot. Example 4, we're not going to create this graph here. Let's skip the number 2. Describe the correlation illustrated by each scatter plot. Here we have turnpike tolls, and the x-axis is the number of miles that you travel, and this is number of tolls, the amount of money that you pay in tolls. If you've never been on a toll road, there are roads in our country, especially out east, up around New York City, and you drive through New Jersey, there's a turnpike, and you drive for a while, go through a toll booth stall, that's where you're going to pay money, and you pay money and you drive till you get the next one. And obviously the further you drive, the more you spend. So this is going to be a positive correlation. It's going up because the further that you drive, the more you spend. Both are increasing. Movie circulation is the title. We have weeks since the movie released and rentals per week. So this textbook was probably written whenever there was such a store as Blockbuster. But nonetheless, Blockbuster would come out and you'd be down there trying to get the new releases, and because they were on VHS tapes and everyone's in the store, and you stand around waiting for someone to turn one in the inbox so you could check it out. Thinking of way back in the days of Rambo. So whenever it's first released, there's a lot of people renting it. Well, as time goes by, people have seen it, so the number of rentals gets lower and lower and lower. So we could say that as the number of weeks since the movie was released increases, the number of rentals is going to decrease. And we can see that that would be a negative correlation. Identify the correlation you expect to see between each pair of data sets and explain the volume of water poured into a container and the amount of empty space left in the container. Well, as the amount of water increases, the volume is going to decrease. So that would be a negative correlation. One's increasing, the other's decreasing. A person's shoe size and the length of a person's hair. That one, I don't think there's any correlation. I got pretty long hair. And I know other people have pretty long hair, and we have different or hair that's long. My hair is both long and pretty, I suppose. But nonetheless, I don't think there's any correlation between a person's shoe size and the length of their hair. And number 9, the outside temperature and the number of people at the beach. Well, the hotter it gets, the more people show up. So as the temperature increases, the number of people at the beach increase. Unless the movie Jaws just came out. I was 12. I didn't go swimming all summer. Choose a scatter plot that best represents the described relationship and explain. Um, let's see. The age of a car and the number of miles traveled. Well, the older the car gets, we're assuming you're driving it, then the number of miles traveled is going to increase. So that would be a positive correlation. Looks like maybe graph B. As the age of the car increases, number of miles increases. The age of a car and the sale price of a car. Unless you can't get computer chips. But we're assuming that as the car gets older, the car has less value. So as the age increases, then the value decreases. We can see that here in graph A. At the time of this recording, the truck that I paid $42,000 for 2 years ago, I put about an extra 65, 70,000 miles on it in the last 2 years. I could probably sell it for 50,000 right now. Google it if you're watching this many, many years after the year of 2022. And then finally, the age of the car and the number of states traveled to. How old your car doesn't necessarily determine the number. There's no relation between how old your car is and how many states that you travel to. And then over here, we're going to put a trend line in here. So we need a trend line for this one, and I'm going to use something other than red since our points are red. I guess is blue going to show up on here? Yeah, it looks like blue will show up okay on that. So we're going to try to put a trend line in, trying to keep about as many above as there are below. Keep about 4 above, 4 below. So maybe if I went something like this might be okay, right? And now the scatter plot shows the total number of miles passengers flew on U.S. domestic flights in the month of April for the years 1997 to 2004. Wow, that's like 18 years ago. It's probably an old textbook. Based on this relationship, predict how many miles passengers flew in 2008. Well, it looks like first we have to be careful to make sure that the years down here that we're counting those right. From 02 to 6, what is that? 1, 2, 3, 4. Yep, each one's a year. So go 2 more. This must be 08 right there. And so we're going to go up to that. And if we were right there, so we could figure that, how many people would that be? Looks like they're counting by 2, right? Actually, it's by billions, right? It's not that, yeah, 50 people flew on the plane. More than 50 people took a flight. It is in billions. So it looks like this number right here is going to be about maybe 50. It's right in between 46. No, take it back, take it back. I'm getting 2 50s up there. 47, right? There we go. About 47, but not 47 people, 47, that is billion. There we go, billion. So we could expect for about 47 billion people to fly in the year 2008. Somewhere way down this graph is 2020, 2021, where it suddenly dropped because everybody was quarantined in home with COVID. One thing I want to point out is that notice this little squiggly here, this little scritch scratch type thing here. Um, the reason for that is it lets you know that there is data missing. This value right here for y, that might be 0. Well, it is 0. But what it means is that everything from like 37 down to 0 or 1 or whatever is not represented on the graph. This little squiggly zigzag here lets you know that there is more there. Otherwise, if they actually graphed it, if they left it there, uh, and they want to kind of focus in on, as I point at my screen, like you can see me pointing in person, as you focus in on these numbers here, if they put all that in, then the graph would be really, really tall, and there'd be a whole bunch of empty data way down at the bottom. But that's what that little squiggly's for. All right, so that's everything I got for Algebra 1, Chapter 4, Lesson 5, scatter plots and trend lines. Now, go level up your learning.